Part 1, Chapter 4 of A Popular History of Astronomy During the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. A Popular History of Astronomy During the 19th Century by Agnes Mary Clerke. Chapter 4, Planetary Discoveries, Part 2. Sir George Bedell Airy had begun in 1835 his long and energetic administration of the Royal Observatory, and was already in possession of data vitally important to the momentous inquiry then on foot. At his suggestion and under his superintendence, the reduction of all the planetary observations made at Greenwich from 1750 onwards had been undertaken in 1833. The results, published in 1846, constituted a permanent and universal stock of materials for the correction of planetary theory. But in the meantime, investigators, both native and foreign, were freely supplied with the places and errors, which, clearly exhibiting the discrepancies between observation and calculation, between what was and what was expected, formed the very groundwork of future improvements. Mr. Adams had no reason to complain of official discourtesy. His labours received due and indispensable aid, but their purpose was regarded as chimerical. "I have always," Sir George Airy wrote, "considered the correctness of a distant mathematical result to be a subject rather of moral than of mathematical evidence," and that actually before him seemed, from its very novelty, to incur a suspicion of unlikelihood. No problem in planetary disturbance had heretofore been attacked, so to speak, from the rear. The inverse method was untried, and might well be deemed impracticable, for the difficulty of determining the perturbations produced by a given planet is small, compared with the difficulty of finding a planet by its resulting perturbations. Laplace might have quailed before it, yet it was now grappled with as a first essay in celestial dynamics. Moreover, Adams unaccountably neglected to answer, until too late, a question regarded by Airy in the light of an experimentum crucis as to the soundness of the new theory. Nor did he himself take any steps to obtain a publicity which he was more anxious to merit than to secure. The investigation consequently remained buried in obscurity. It is now known that, had a search been instituted in the autumn of 1845 for the remote body whose existence had been so marvellously foretold, it would have been found within 3½ lunar diameters, 1° 49' of the spot assigned to it by Adams. A competitor, however, equally daring and more fortunate, audax fortuna adjutus, as Gauss said of him, was even then entering the field. Urbain Jean Joseph Le Verrier, the son of a small government employé in Normandy, was born at Saint-Lô, March 11, 1811. He studied with brilliant success at the École Polytechnique, accepted the post of astronomical teacher there in 1837, and, docile to circumstance, immediately concentrated the whole of his vast, though as yet undeveloped, powers upon the formidable problems of celestial mechanics. He lost no time in proving to the mathematical world that the race of giants was not extinct. 2 papers on the stability of the solar system, presented to the Academy of Sciences September 16 and October 14, 1839, showed him to be the worthy successor of Lagrange and Laplace, and encouraged hopes destined to be abundantly realized. His attention was directed by Arago to the Uranian difficulty in 1845, when he cheerfully put aside certain intricate cometary researches upon which he happened to be engaged, in order to obey with dutiful promptitude the summons of the astronomical chief of France. In his first memoir on the subject, communicated to the Academy November 10, 1845, he proved the inadequacy of all known causes of disturbance to account for the vagaries of Uranus. In a second, June 1, 1848, he demonstrated that only an exterior body, occupying at a certain date a determinate position in the zodiac, could produce the observed effects. In a third, August 31, 1846, he assigned the orbit of the disturbing body, and announced its visibility as an object with a sensible disk about as bright as a star of the 8th magnitude. The question was now visibly approaching an issue. On September 10, Sir John Herschel declared to the British Association respecting the hypothetical new planet, "We see it as Columbus saw America from the coast of Spain. Its movements have been felt, trembling along the far-reaching line of our analysis, with a certainty hardly inferior to that of ocular demonstration." Less than a fortnight later, September 23, Professor Gall of the Berlin Observatory received a letter from Leverrier, requesting his aid in the telescopic part of the inquiry already analytically completed. He directed his refractor to the heavens that same night, and perceived, within less than a degree of the spot indicated, an object with a measurable disk nearly 3 seconds in diameter. Its absence from Bremiker's recently completed map of that region of the sky showed it to be no star, and its movement in the predicted direction confirmed without delay the strong persuasion of its planetary nature. In this remarkable manner the existence of the remote member of our system, known as Neptune, was ascertained; but the discovery, which faithfully reflected the duplicate character of the investigation which led to it, had been already secured at Cambridge before it was announced from Berlin. Sir George Airy's incredulity vanished in the face of the striking coincidence between the position assigned by Leverrier to the unknown planet in June, and that laid down by Adams in the previous October; and on the 9th of July he wrote to Professor Challis, director of the Cambridge Observatory, recommending a search with the great Northumberland equatoreal. Had a good star map been at hand, the process would have been a simple one; but of Bremiker's Hora 21 no news had yet reached England, and there was no other sufficiently comprehensive to be available for an inquiry which, in the absence of such aid, promised to be both long and laborious. As the event proved, it might have been neither. After 4 days of observing, Challis wrote October 12, 1846, to Airy, "The planet was in my grasp, if only I had examined or mapped the observations." Had he done so, the first honours in the discovery, both theoretical and optical, would have fallen to the University of Cambridge. But Professor Challis had other astronomical avocations to attend to, and moreover his faith in the precision of the indications furnished to him was, by his own confession, a very feeble one. For both reasons he postponed to a later stage of the proceedings the discussion and comparison of the data nightly furnished to him by his telescope, and thus allowed to lie, as it were, latent in his observations, the momentous result which his diligence had ensured, but which his delay suffered to be anticipated. Nevertheless, it should not be forgotten that the Berlin astronomer had 2 circumstances in his favour, apart from which his swift success could hardly have been achieved. The first was the possession of a good star map. The second was the clear and confident nature of Leverrier's instructions. "Look where I tell you," he seemed authoritatively to say, "and you will see an object such as I describe." And in fact, not only Galle on the 23rd of September, but also Challis on the 29th, immediately after reading the French geometer's lucid and impressive treatise, picked out from among the stellar points strewing the zodiac a small planetary disk, which eventually proved to be that of the precise body he had been in search of during 2 months. The controversy that ensued had its ignominious side, but it was entered into by neither of the parties principally concerned. Adams bore the disappointment which the dilatory proceedings at Greenwich and Cambridge had inflicted upon him with quiet heroism. His silence on the subject of what another man would have called his wrongs remained unbroken to the end of his life, and he took every opportunity of testifying his admiration for the genius of Leverrier. Personal questions, however, vanish in the magnitude of the event they relate to. By it the last lingering doubts as to the absolute exactness of the Newtonian law were dissipated. Recondite analytical methods received a confirmation brilliant and intelligible even to the minds of the vulgar, and emerged from the patient solitude of the study to enjoy an hour of clamorous triumph. For ever invisible to the unaided eye of man, a sister globe to our earth was shown to circulate in perpetual frozen exile at 30 times its distance from the sun. Nay, the possibility was made apparent that the limits of our system were not even thus reached, but that yet profounder abysses of space might shelter obedient, though little favoured, members of the solar family, by future astronomers, to be recognized through the sympathetic thrillings of Neptune, even as Neptune himself was recognized through the tell-tale deviations of Uranus. It is curious to find that the fruit of Adams's and Leverrier's laborious investigations had been accidentally all but snatched half a century before it was ripe to be gathered. On the 8th, and again on the 10th of May, 1795, Lalande noted the position of Neptune as that of a fixed star, but perceiving that the two observations did not agree, he suppressed the first as erroneous, and pursued the inquiry no further. An immortality which he would have been the last to despise hung in the balance. The feather weight of his carelessness, however, kicked the beam, and the discovery was reserved to be more hardly won by later comers. Bode's law did good service in the quest for a trans-Uranian planet, by affording ground for a probable assumption as to its distance. A starting point for approximation was provided by it, but it was soon found to be considerably at fault. Even Uranus is about 36 millions of miles nearer to the sun than the order of progression requires, and Neptune's vast distance of 2,800 millions should be increased by no less than 800 million miles, and its period of 165 lengthened out to 225 years, in order to bring it into conformity with the curious and unexplained rule which planetary discoveries have alternately tended to confirm and to invalidate. Within 17 days of its identification with the Berlin achromatic, Neptune was found to be attended by a satellite. This discovery was the first notable performance of the celebrated 2-foot reflector, erected by Mr. Lassell at his suggestively named residence of Starfield, near Liverpool. William Lassell was a brewer by profession, but by inclination an astronomer. Born at Bolton in Lancashire, June 18, 1799, he closed a life of eminent usefulness to science. October 5, 1818, thus spanning with his well-spent years 4/5 of the momentous period which we have undertaken to traverse. At the age of 21, being without the means to purchase, he undertook to construct telescopes, and naturally turned his attention to the reflecting sort, as favouring amateur efforts by the comparative simplicity of its structure. His native ingenuity was remarkable, and was developed by the hourly exigencies of his successive enterprises. Their uniform success encouraged him to enlarge his aims, and in 1844 he visited Birr Castle for the purpose of inspecting the machine used in polishing the giant speculum of Parsonstown. In the construction of his new instrument, however, he eventually discarded the model there obtained, and worked on a method of his own, assisted by the supreme mechanical skill of James Nasmyth. The result was a Newtonian of exquisite definition, with an aperture of 2 and a focal length of 20 feet, provided by a novel artifice with the equatorial mounting, previously regarded as available only for refractors. This beautiful instrument afforded to its maker, October 10, 1846, a cursory view of a Neptunian attendant; but the planet was then approaching the sun, and it was not until the following July that the observation could be verified, which it was completely, first by Lassell himself, and somewhat later by Otto Struve and Bond of Cambridge, U.S. When it is considered that this remote object shines by reflecting sunlight, reduced by distance to 1/900th of the intensity with which it illuminates our moon, the fact of its visibility, even in the most perfect telescopes, is a somewhat surprising one. It can only, indeed, be accounted for by attributing to it dimensions very considerable for a body of the secondary order. It shares with the moons of Uranus the peculiarity of retrograde motion; that is to say, its revolutions, running counter to the grand current of movement in the solar system, are performed from east to west, in a plane inclined at an angle of 35 degrees to that of the ecliptic. Their swiftness serves to measure the mass of the globe round which they are performed; for while our moon takes 27 days and nearly 8 hours to complete its circuit of the earth, the satellite of Neptune, at a distance not greatly inferior, sweeps round its primary in 5 days and 21 hours, showing, according to a very simple principle of computation, that it is urged by a force 17 times greater than the terrestrial pull upon the lunar orb. Combining this result with those of Professor Barnard's and Dr. C.'s recent measurements of the small telescopic disc of this farthest known planet, it is found that while in mass Neptune equals 17, in bulk it is equivalent to 49 earths. This is as much as to say that it is composed of relatively very light materials, or more probably of materials distended by internal heat, as yet unwasted by radiation into space, to about 5 times the volume they would occupy in the interior of our globe. The fact, at any rate, is fairly well ascertained, that the average density of Neptune is about twice that of water. We must now turn from this late recognised member of our system to bestow some brief attention upon the still fruitful field of discovery offered by one of the immemorial five. The family of Saturn, unlike that of its brilliant neighbour, has been gradually introduced to the notice of astronomers. Titan, the sixth Saturnian moon in order of distance, led the way, being detected by Huggins, March 25, 1655. Cassini made the acquaintance of 4 more between 1671 and 1684, while Mimas and Enceladus, the 2 innermost, were caught by Herschel in 1789, as they threaded their lucid way along the edge of the almost vanished ring. In the distances of these 7 revolving bodies from their primary, an order of progression analogous to that pointed out by Titius in the planetary intervals, was found to prevail, but with one conspicuous interruption, similar to that which had first suggested the search for new members of the solar system. Between Titan and Japetus, the sixth and seventh reckoning outwards, there was obviously room for another satellite. It was discovered on both sides of the Atlantic simultaneously on the 19th of September, 1848. Mr. W. C. Bond, employing the splendid 15-inch refractor of the Harvard Observatory, noticed September 16 a minute star situated in the plane of Saturn's rings. The same object was discerned by Mr. Lassell on the 18th. On the following evening, both observers perceived that the problematical speck of light kept up with, instead of being left behind by, the planet as it moved, and hence inferred its true character. Hyperion, the seventh by distance and eighth by recognition of Saturn's attendant train, is of so insignificant a size when compared with some of its fellow moons (Titan is but little inferior to the planet Mars), as to have suggested to Sir John Herschel the idea that it might be only one of several bodies revolving very close together, in fact an asteroidal satellite, but the conjecture has so far not been verified. The coincidence of its duplicate discovery was singularly paralleled 2 years later. Galileo's amazement when his optic glass revealed to him the triple form of Saturn, Planeta Tergeminus, has proved to be, like the laughter of the gods, inextinguishable. It must revive in every one who contemplates anew the unique arrangements of that world apart, known to us as the Saturnian system. The resolution of the so-called ansae, or handles, into one encircling ring by Huggins in 1655, the discovery by Cassini in 1675 of the division of that ring into two concentric ones, together with Laplace's investigation of the conditions of stability of such a formation, constituted, with some minor observations, the sum of the knowledge obtained up to the middle of the last century on the subject of this remarkable formation. The first place in the discovery now about to be related belongs to an American astronomer. William Cranch Bond, born in 1789 at Portland, in the state of Maine, was a watchmaker whom the solar eclipse of 1806 attracted to study the wonders of the heavens. When in 1815 the erection of an observatory in connection with Harvard College, Cambridge, was first contemplated, he undertook a mission to England for the purpose of studying the working of similar institutions there, and on his return erected a private observatory at Dorchester, where he worked diligently for many years. Then at last, in 1843, the long postponed design of the Harvard authorities was resumed, and on the completion of the new establishment, Bond, who had been from 1838 officially connected with the college, and had carried on his scientific labours within its precincts, was offered and accepted the post of its director. Placed in 1847 in possession of one of the finest instruments in the world, a masterpiece of Merz and Mahler, he headed the now long list of distinguished transatlantic observers. Like the elder Struve, he left an heir to his office and to his eminence, but George Bond unfortunately died in 1865 at the early age of 39, having survived his father but 6 years. On the night of November 15, 1850, the air, remarkably enough, being so hazy that only the brightest stars could be perceived with the naked eye, William Bond discerned a dusky ring extending about halfway between the inner brighter one and the globe of Saturn. A fortnight later, but before the observation had been announced in England, the same appearance was seen by the Rev. W. R. Dawes, with the comparatively small refractor of his observatory at Wateringbury, and on December 3 was described by Mr. Lassell, then on a visit to him, as something like a crape veil covering a part of the sky within the inner ring. Next morning the Times, containing the report of Bond's discovery, reached Wateringbury. The most surprising circumstance in the matter was that the novel appendage had remained so long unrecognized. As the rings opened out to their full extent, it became obvious, with very moderate optical assistance. Yet some of the most acute observers who have ever lived, using instruments of vast power, had heretofore failed to detect its presence. It soon appeared, however, that Gall of Berlin had noticed, June 10, 1838, a veil-like extension of the lucid ring across half the dark space, separating it from the planet. But the observation, although communicated at the time to the Berlin Academy of Sciences, had remained barren. Traces of the dark ring, moreover, were found in drawings executed by Campini in 1664 and by Hooke in 1666, while Picard, June 15, 1673, Hadley, spring of 1720, and Herschel had all undoubtedly seen it under the aspect of a dark bar or belt crossing the Saturnian globe. It was then of no recent origin, but there seemed reason to think that it had lately gained considerably in brightness. The full meaning of this suspected change it was reserved for later investigations to develop. What we may, in a certain sense, call the closing result of the race for discovery, in which several observers seemed at that time to be engaged, was the establishment on a satisfactory footing of our acquaintance with the dependent system of Uranus. Sir William Herschel, whose researches formed in so many distinct lines of astronomical inquiry the starting points of future knowledge, detected January 11, 1787, 2 Uranian moons, since called Oberon and Titania, and ascertained the curious circumstance of their motion in a plane almost at right angles to the ecliptic, in a direction contrary to that of all previously known denizens, other than cometary, of the solar kingdom. He believed that he caught occasional glimpses of 4 more, but never succeeded in assuring himself of their substantial existence. Even the 2 first remained unseen, save by himself, until 1828, when his son reobserved them with a 20-foot reflector, similar to that with which they had been originally discovered. Thenceforward they were kept fairly within view, but their 4 questionable companions, in spite of some false alarms of detection, remained in the dubious condition in which Herschel had left them. At last, on October 24, 1851, after some years of fruitless watching, Lassell espied Ariel and Umbriel, 2 Uranian attendants, interior to Oberon and Titania, and of about half their brightness, so that their disclosure is still reckoned amongst the very highest proofs of instrumental power and perfection. In all probability they were then for the first time seen, for although Professor Holden made out a plausible case in favour of the fitful visibility to Herschel of each of them in turn, Lassell's argument that the glare of the planet in Herschel's great specula must have rendered almost impossible the perception of objects so minute, and so close to its disk, appears tolerably decisive to the contrary. Uranus is thus attended by 4 moons, and, so far as present knowledge extends, by no more. Among the most important of the negative results secured by Lassell's observations at Malta during the years 1852-53 and 1861-65 were the convincing evidence afforded by them that, without great increase of optical power, no further Neptunian or Uranian satellites can be perceived, and the consequent relegation of Herschel's baffling quartet, notwithstanding the unquestioned place long assigned to them in astronomical textbooks, to the nirvana of non-existence. End of chapter 4.